1 is equal to 8.624 mole hydrogen. 17.27 gram nitrogen times 1 mole over 14.0 is equal to 1.
Next step is to calculate the molar ratios of these elements relative to the least abundant element, and in this case it is nitrogen. The carbon to nitrogen and hydrogen to nitrogen molar ratios are adequately close to whole numbers, and so the empirical formula is C5H7N. Then we calculate the molar mass for nicotine from the given mass and molar amount of compound. So 40.57 grams of nicotine divided by 0.2500 mole of nicotine, that would be equal to 162.3 grams per mole. Comparing the molar mass and empirical formula mass indicates that each nicotine molecule contains 2 formula units.
You can now derive the molecular formula for nicotine from the empirical formula by multiplying each subscript by 2. So you will have 5 times 2 for carbon, that would be 10. For hydrogen, 7 times 2, and nitrogen, 1 times 2. So the molecular formula for nicotine will be C10H14N4. Work on. But before that, let's try to compare first between empirical and molecular formula. So the empirical formula is the simplest form of expressing the elemental composition of a compound. The molecular formula is the actual representation of the elemental composition of a compound. Empirical formula is derived first from the weight percentages of the element present in the compound, while molecular formula related to the weight of the compound in question and often is derived after obtaining the empirical formula. The empirical formula contains the most simplified ratio of the moles of elements in a compound, while molecular formula needs to be a multiple of the empirical formula. The empirical formula is not often used in reaction schemes, while molecular formula is commonly used in reactions and other chemical recordings. So let's now go to your activities on your worksheets. For you to have some more exercises and problem solving involving molecular formula. So you have activity 1, which you are going to determine which are having the same molecular formula and empirical formula. For activity 2, you will determine the molecular formula of each compound given the empirical formula and molecular mass. And activity 3, you will determine the empirical and molecular formula of each compound given the percent composition and the molecular mass. You will work on that later on. Now let us try to summarize what we have discussed. So you complete the given concept map by filling up the boxes with the appropriate concepts using the linking word phrases as guide on how these concepts are related to each other. So you are given the concept map. Fill this up with the different. So this would be your concept map. Chemists, doctors, and other experts keep on searching for new chemicals that can be used as coronavirus vaccine because they believe that it is the only way by which we can prevent the rapid spread of coronavirus. Furthermore, the skills and the ability of chemists to synthesize, formulate, and identify unknown components of substances will be of great help in this time of continuous struggle to come up for the appropriate formulation of coronavirus. In what ways the knowledge on empirical formula and molecular formula of substances can be useful for a chemist in performing toxicological and chemical analysis of the structure of coronavirus? After your senior high school, do you want also to be a chemist? What career path do you intend to pursue? You may write or you encode your answer and then send it to my account. Let's now have your post-test. Let us try to determine how well you were able to understand our discussion. Choose the letter of the best answer. Number 1. Which statement does not describe a molecular formula? A. It describes the exact number and types of atoms in a single molecule of compound. B. It indicates the simplest whole number ratio of all the atoms in the molecule. C. It describes the exact number and the type of atoms in a single molecule of a compound. It expresses information about the proportions of atoms that constitute a compound. Number 2. Compound of carbon and hydrogen contains 92.3% carbon and has a molar mass of 78.1% gram per mole. What is its molecular formula? A. CH, B. C3H3, C. C6H6, letter D. C2H2. Number 3. Dichloroethane, a compound that is often used for drying, cleaning, contains carbon, hydrogen, and chlorine. It has a molar mass of 99 gram per mole. Analysis of a sample shows that it contains 24.3% carbon and 4.1% hydrogen. What is its molecular formula? A. C2H4Cl2, B. C2H2Cl2, C. CH2Cl2, letter D. CHCl2. Number 4. What is the molecular mass of the compound having the empirical formula CH4N and molecular mass of 78 AMU? A. CHN, B. C3H3N, C. C3H6N, and letter D. C3H12N3. Number 5. If a compound has a molecular mass of 32 AMU and having an empirical formula of NH2, what is molecular formula of the compound? A. NH4, B. N2H6, C. N2H4, D. N2H2. Let's now check your answers. Number 1, B. 2C, 3A, 4D. Okay, did you get it right? That means you know now how to determine the molecular formula of compounds. For your other questions, you will reserve it when we have our scheduled meetings. So bye now and stay safe. Okay, did you get it right? That means you know now how to determine the molecular formula of compounds. For your other questions, you will reserve it when we have our scheduled meetings. So bye now and stay safe.